Um, so I'm going to talk about observability-driven development, which is absolutely a term that I made up. But it's a thing that needs to exist. I welcome alternatives. If you have a better term for it, great, because it's kind of a crappy term. But it's not a crappy idea. Well, all computer shit is crappy, but besides that. My name is Charity. Let's see. I have done a bunch of things. I was the first infrastructure engineer at Linden Lab for Second Life a bunch of years ago. I was the first infrastructure engineer at Parse, the mobile backend as a service. I was there through the Facebook acquisition. That experience of trauma is what led me to create Honeycomb. I wrote the database reliability engineering book. And if you happen to have a copy of this, I did bring some unicorns to fix the cover. You can't have a mythical creature as your creature, so we picked a horse, and we can fix it with stickers to get the fucking horn and tail. So see me after class if you need one. So what I want to talk about today is, this is actually a new talk, as you could see by the fact that I was madly writing slides right up until the last second. This is something that's been, and I actually emailed them and I asked if I could come talk to you guys, because I've been wanting to come to a GopherCon for a long-ass time, and this felt like a nice out-of-the-way corner of the world for me to totally fuck up and fall on my face, and nobody will ever know, right? But I want to talk about the evolution that I feel like I'm seeing from TDD, like what comes next, and why it matters, and how you do it. So. And along the way, we'll talk a little bit about other things that I care a lot about that happen to matter for the story, like observability and complex systems and all that stuff. So let's review. TDD is a methodology that says, you write some code, it doesn't really, you write some tests, you write some code, they don't work, you go back, you fix it, whatever. I don't know. You all probably know this. You're software engineers, right? Are you all software engineers? Raise your hand if you're a software engineer. Woo-hoo! Raise your hand if you're not. Cool, good for you, 5 people. So TDD was like a really huge leap forward for us as an industry. People die from bad code every single day, don't forget. This is now table stakes, and that's great. But TDD has a couple of pretty serious problems baked into it that weren't really a big deal for a long time, but are becoming an increasingly big deal for reasons that we will explore. There are reasons that make it increasingly insufficient as a mental model for how you're developing code. Basically, there are two big reasons that TDD sucks. I mean, not sucks, but doesn't go far enough. Number one, TDD stops where your laptop stops. It stops when it hits the network, effectively. There have been many valiant attempts to make this not true, but it's still true. Even with a monolithic app, this pretty much sucks a lot, right? But now, with microservices and all of this hot new shit that you're doing to yourselves, it really sucks. It's really, really bad. Like, you're diverging from reality more and more, which is not what you want with your tests, right? Number two, it is fundamentally reactive. It can only account for your known unknowns. For those of you, I come from much more of an operations engineering background, and this to me is almost the exact identical parallel to monitoring, right? You can only monitor what you know can break, right? Something breaks, cool, you go back and you add a monitoring check for it so you can find it immediately the next time. Something breaks, you write a test for it so that you catch it before it gets shipped to production next time, right? You're always following along, picking up the trail after the dead bodies, right? So let's talk about some of these terms and why they matter, because I suspect that most of you are not paying quite as much attention to OPSI stuff as ops people. So a couple years ago at Monitorama, Gregory said this, which I loved. He's like, monitoring's dead, it's broken. And the way he defined monitoring was the action of observing and checking the behavior and outputs of a system and its components over time. It is honestly no longer practically possible to keep up with the sea of alerts that most systems will generate. It's fucking broken. And like, monitoring hasn't changed in 20 years. 20 years ago, when they first wrote that ugly piece of shit called Nagios, the angry fruit salad of doom, right? It looked exactly the same as it does today, minus a CSS upgrade. I don't know, or not. I can't tell. Like, it has not changed. We're still mopping up crap after our system shit it out. It burns out your humans, doesn't make your systems better, and you're not getting ahead of what's breaking. So, okay, it's easy to crap all over technology. It's easy to talk about what's broken, because it's all kind of broken. What do we have to propose in its place? And this is where observability comes in. Observability is actually, it's a term that's taken from control theory, as the Wikipedia page will tell you all about it. But when you apply it to software, to me this means how much can you understand the inner workings of your complex software system just by observing and asking questions from the outside, without shipping new code, right? It's easy to ask questions that you could predict you would have, or that you have had before, and you will presumably have again. But finding that right level of abstraction where you can ask any arbitrary new ad hoc question and understand what's happening when it's never happened before, that's observability. And this is like a topic of some annoying debates right now, like, should they be this, do they really mean different things, monitoring and observability, or do they not? Whatever. I think that it's worth making a distinction because the best practices for monitoring versus observability are often diametrically opposed. So in my mind, it's more clarifying to have two words for two meanings. If you want to argue with me about that, I will be at the bar and not arguing with you about that. Yeah, I can't really see what my slides are. All right, there's the definition. Cool. That's the control theory definition. This is what I would say it means when you apply it to software. If you have to ship new code just to ask a new question, that sucks. That says something bad about the level of abstraction in which you're instrumenting your code. So, you can kind of think of them this way. And this is not 100% true. Don't send your goons after me. But like, monitoring is very much about operating your system, dealing with it kind of like a black box you may or may not have commit privileges to. And observability is about a system that you have commit privileges to, that you commit code to. It's a system that you can plunge your fist into its bleeding heart and make it explain itself back to you, like civilized folk. And because of that, I associate it much more with software engineers, right? And I don't say this as a slam. Monitoring is for how you operate a service. And observability, instrumentation, is how you develop a service. Obviously, our roles are all intermingled, and that's great. You have an observable system when your team can quickly and reliably ask any new question and track down any new problem without anticipating it or predicting it or shipping new code. And this is all about moving problems from the pile marked unknown unknowns, where it's always an engineering problem, it's always open-ended, it takes your creativity and your engaged self, and putting it in the support pile, right? Where it's a known unknown, where you've seen it before. It should not be as hard to deal with it the second time around. Known unknowns are great, they're easier to deal with, and we should be in the business of making more of them. This matters, though, because complexity is, we're all kind of driving our car off this cliff together, and yet we're all using systems and tools that were mostly developed in the LAMP stack era. There are often tells. The tool will rely on things like schemas, or indexes, or metrics, or they strip all the context away, or they aggregate instead of sampling, all kinds of tells. Our tools are generally designed to answer known questions fast. Doesn't really help you when what you're dealing with is something where you're like, okay, I have a bunch of reports that I may or may not trust. I believe something is probably wrong. I don't know what. If I knew what the fucking question was, I could tell you the answer, but I don't know what the question is, which is increasingly the category of problems that I find myself dealing with. And it's pretty easy to just visualize the change over the last 20 years and the complexity of our systems, right? LAMP stack, ooh, am I going to pick MySQL or Postgres today? I don't know, so tough. Right? And there's Parse, circa 2015. This is the national electrical grid for my country. And if your mental model is for that kind of a system, it's going to be hard to deal with these systems. They aren't necessarily hard systems to deal with, but it's a different mental model. There are some problems that you're only going to be able to tell or detect if you zoom way in, right? A tree fell over on Main Street in bumfuck Ohio. You're not going to be able to predict that, probably, unless you cut down the tree. And you're also not going to be able to detect it at a macro level. There are some problems that you're only going to be able to detect if you zoom way out, right? Like all bolts that were manufactured in 1984 are rusting twice as fast, you know? So, you know, you can only see that if you zoom way out. It's a different way of thinking about things. So I'm a music major dropout, not a computer scientist, so I just drew a graph so you would know it was true. You know. All these things are kind of happening at once and amplifying each other. They're related. Bottom line, welcome to distributed systems. I'm pretty sure you can ask for a raise now. It's probably fine. It's probably not fine, but that's fine too. The first lesson of distributed systems is your system's never actually working. It's just not. If you think it is, your tooling sucks. If you have a wall full of beautiful green dashboards telling you that your world is safe, it's lying to you, and you probably shouldn't sleep well at night. And it's a lie that turns toxic with these complex distributed systems, because we start to believe that if we haven't graphed it and it isn't red, it must not exist. This matters a lot for this audience because we're going to talk about the process of building and shipping software. And distributed systems, the kind that we're all increasingly working on, are extremely hard. They're not hard. They're impossible to duplicate and clone and get any meaningful results out of past a certain point. You know, I worked at Facebook. They did not spin up a copy of Facebook to test Facebook with their Facebook. You can't spin up a copy of the national power grid. Okay, you could. It is cost prohibitive. Then you have to deal with clients, concurrency, you know, capturing transaction and replaying an order. Bottom line is you really shouldn't try. Some things aren't amenable to cloning, and that's fine. You can't mimic the qualities of size and chaos that tease out this infinitely long, thin tail of things that almost never happen, except that once they do. Or once like 4 or 5 very rare things have to intersect, and then they do. These slides are hilarious. Yeah. Staging environments don't really work very well for distributed systems. So, this is a long prelude, but where does this bring us? Testing and production. This is a bit of an inflammatory statement, which is why I like it. But I nevertheless stand behind it because you do test in production. I don't care what you say about whether you do or not. You do. You have to. There's no way around it. Every single time that you deploy a unique combination of using this software to deploy that bundle to these hosts for this version, it is a unique combination. And if you simply change one of those things, like target equals staging instead of production or whatever, you know, you're not testing, did I typo production? You know, it is a unique combination. There's no way around it. And the more that we try to resist it, the more we take our very scarce, precious engineering cycles, and instead of investing them into making our testing and production resilient and robust and not scary, we tend to pour it all into this very fragile idea that we can stave off all problems by running everything in staging first. But there is no substitute for all of these things. There is no substitute, and these are the most important things that you probably care about. And so it's worth doing this well. It's worth investing in things like canaries, you know, that automatically promote. It's worth investing in high cardinality tooling that lets you compare versions, having multiple versions of flight, blah, blah, blah. I'm digressing slightly. I'm going to move it along because I know we're running behind. It's misleading to say that we don't test in production. I blame this dude. Like, this was a really funny meme for a while. But like, I realized after a while that people were hearing this as, you can only test before production or in production, in which case that would be a terrible idea. But what if I told you you could do both? It's not like there's a limit on the number of tests you're allowed to run, I assume. I don't really know how software engineering works, so. Nobody really likes the phrase test in production, though. It's scary. Managers hate it. So, like rules of thumb, here are things to test before prod. These are the very, very dead simple things, right? Which is great. It's good to test simple things. 80% of the problems can be caught with 20% of the tests. There is a link in here of some paper that Katie McCaffrey even put it. A computer scientist said so, so I believe it. That was a joke, in case you weren't. Things you test in production. Literally anything that's interesting, right? There are so many questions that we have to ask about what's happening in production right now, what's happening in our systems that have nothing to do with outages, that have nothing to do with, failure. We're just curious. We just want to know. And we can sit here and hypothesize, we can construct these incredibly elaborate offline staging environments, or we can just safely test. One of the first things so when I was at Parse, we actually made the decision to rewrite everything from Ruby to Golang this would have been 2014? So it was very early. Like, it was not at all clear that this was going to be a winning language or environment, but we were very passionate about it. And we had to build a lot of shit from scratch, let me tell you. And one of the things that we did first for testing this was we were doing the rewrite endpoint by endpoint, right? And we built a splitter. It was kind of like a shitty version of, not Envoy, but Turbine, of Go Turbine. Shitty version of Go Turbine. We just fork every request that came in, and send one request to the Ruby API, and send that one back to the user, send the other copy to the Go API, and then we'd diff them, just keep a log of the responses that were different. And then we just start whacking off all of the types. Super fun. What are we going to do? Run that in staging? No, it was stupid. There are so many ways to test that your users will never see it, right? Feature flags, amazing for this. Launch darkly is awesome. It's another thing that we kind of built ourselves back before we had nice things. There are a lot of tools out there for doing these things. Testing, maybe we should just use the word experimenting. I don't know, experimenting on users, is that better? Maybe not. Not all failures are created equal. I am pretty passionately against staging environments now. I will admit that this is a religious stance. There are good reasons that still exist to use staging environments. It's fine. They're complementary. Only production is production. Every deploy is a unique exercise. So, I'm getting to the point here, which is, well, this is one point. Observability. Most people have such bad observability that it's not that they don't want to run tests in production, it's that they honestly wouldn't know if something broke if they did. And that was kind of sad. There's that link I was talking about. I swear these slides were in a different order on my laptop. You have a limited amount of energy, spend it wisely. So, observability-driven development is using real production data. It's taking the testing and production component that we just talked about, but that's not all, right? Because this is end-to-end development. It's also using production to inform, is this even worth building or not, right? It's using production from, this might be an interesting feature to build. We'll walk through the full life cycle of one of these, but all the way through shipping it safely, telling if you had shipped it safely, shipping it in, whatever staged rolling thingamajigger you're doing, whatever. Using production data in real time. Now let's talk about DevOps. I'm trying to go so fast. DevOps. So, I feel like wave one of DevOps was, okay, ops people, time to learn to write code, right? This was like 10 years ago. I was like, okay, like message received. We all learned to write software. And it was good. It was a good lesson for us. It was a necessary sea change in the industry. And I really feel like in the last 2 years or so, the pendulum has swung in the other direction, finally. And it's like, okay, software engineers, your turn. It is time to learn to write operable services. Thank you. And to be on call. I am not expecting you to clap for that one as much, but it's necessary. And on call does not have to be hell, and it shouldn't be hell. That's another talk, though. Science shows us that ownership is the goal here, right? It's not about what you do. It's not about what your role is. It's not about what your function is. It's not telling everybody that they must learn to do all things equally well. Because bullshit. Of course you don't. You can't, and you shouldn't. People have specialties, and that's great. But there's a lot of power that you unlock by being really good at something and decent or even crappy but literate in an adjacent skill, right? Being able to explain them back to each other. And I'm trying to work with some people to do some more rigorous studies in this, but I keep hearing from people who, when they manage to instill the values of software ownership in their org, and by ownership, to me, that means you have the ability and the access over the full life cycle of the software, from I'm going to develop this, to I'm going to triage, I'm going to fix bugs, I'm going to deploy it, I have the ability to roll back, I can roll forward. Having ownership over that full life cycle of the software, it unlocks a higher, the feedback loop is tight, right? There is nothing that develops your intuition about how to build great software and systems like exposing yourself to some consequences. Seriously. And this doesn't have to be terrible. It can be during the day. But consequences are amazing. And that intuition is, to me, what really separates the amazing senior engineers from the crappy senior engineers, or the non-senior engineers, whatever. And these days, software development is usually very customer-focused. We celebrate shipping, and we kind of forget about it. This is what the developer process looks like. I can't even see my slides, so I'm just going to turn around. Yay, we shipped, woo. And wait for things to complain. Cool. And then an ops person comes along and ruins your day, starts bitching about something breaking. That's my quote. It's basically how I feel about software. Which makes devs kind of go, works on my machine. Whatever happened to our diligence and our curiosity and those beautiful edge cases and tests that we wrote? This us versus them conflict that we get locked into, I mean, it doesn't actually matter, right? Users don't give a shit about our nines. They don't give a shit about our uptime, our bug trackers. They care about their experience. And we should be united in that cause, right? We need to start thinking about the perspective of users, but more importantly, users in production, right? Users actually do not give a shit about what your staging environment looks like for their account either. Imagine that. Production is the key. From the developer's perspective, we can use the data about the users in production to really explore what our services are doing for realsies, not what we told them to do, but what is it actually doing. And this helps us inform what features we build and what bugs we fix, how we scope, how we roll things out. And from the ops' perspective, these are much more standard opsy questions, right? How is our load spread out? We rolled out some optimizations. How is it actually working? These look like different questions, but the nouns, right? The things that we want to drill down by, the things that we want to break down by are always customers, always those high cardinality fields, which, that's another rant. I have too many rants, I'm sorry. So, let's see. Yeah, your nouns might be different. Fast forwarding a little here. Here are some examples of how people currently answer these questions. This is how software engineers answer them, using APM. These are how ops people tend to answer them, using monitoring. To doesn't matter, right? These tools can kind of like create a divide, but this is really tripping me out. I can't see my slides. First wave, I'm just going to fast forward. So let's go back to that slide of the things that all developers do and break them down into some more manageable steps. We can use our intuition. We can use a manager's say-so. This is what matters. This is what we should do. But as engineers, we should be fully able to figure out from our shit in production what needs to be built, right? We have real data coming in, so let's look at some real examples here. This might be kind of a classic example, but had a happy ending. So in Honeycomb, we ingest your events, we let you query over them, we optimize for really fast analytics in our column store, and we also support people wanting to flip back and forth to the raw events that make up any given query. So one of our very large customers was able to run a simple count query just fine, but they were experiencing timeouts when they flipped to the raw data mode, even though these two queries were theoretically exactly the same. So we were able to jump into our data, figure out what was normal in aggregate, and then zoom in on just those two queries that were under examination, and we could tell from the context what was different about these two theoretically identical ones while they were actually in flight, which saved us a whole lot of work by just adding this data to the events as they were in motion and then examining them to see, oh, did what we expected to happen actually happen? Did anything else happen? Yeah, those are the queries. This is another example of the sort of high-level analysis that we can do. This one customer's data, the timestamps they were sending us were splayed all over the place that was causing degraded query performance. So we were able to just go back to the customer and say, by the time it hits us, this is what it looks like. There's nothing worse than a customer reporting to you going, you're down, and you're like, no, don't think so. It looks fine to me. You should at least be able to tell them, you're not hitting my edge, right? Understanding the potential impact of a change, it plays out in other interesting ways too. Sometimes a change will have a direct, obvious impact on users. And sometimes you think it will have a huge impact, and it doesn't. When we were just starting out, we knew that we needed to build in real rate limiting, right, into our API. So we started out with a very dumb, simple in-memory cache, where each server just kind of approximated the rate limit individually by dividing the total rate limit by the number of servers as defined in the autoscaling group, which was fine. Nobody was paying us. But as our traffic grew, there was this unwanted correlation between which server a single request would hit and perhaps pipeline through, and which customers are actually being rate limited. So we needed to spin up a shared cache and clean up this technical debt. But instead of just blindly making the change, because once you get used to not making changes blindly, it is very hard to go back, we wanted to be confident it would behave correctly. So while we were perfecting the logic and the heuristics, we started capturing data in prod to simulate the logic, to see what the steady-state behavior would be without impacting customers. So alongside the logic in the API that calculated the particular request rate limited, we added a bit that calculated what the rate limit would be, and then we just graphed them. I think I have a graph here. Yes. And now we have enough information to assess each case and go to our customers proactively and say, hey, I know you've built your systems assuming that we work this way. It's broken. We're fixing it. It's going to behave this way. Anytime you can go to your customers in advance and let them know that you're about to do something that's going to impact them, they think you're a small god, a demigod. Not a god, but like a minor god. Even when you're doing something that they're going to hate. It's like a superpower. So, and this is an example from the string compression. We wanted to introduce basic compression into our string columns, and we were guessing that datasets with a lot of unique strings, high cardinality datasets, would benefit less from the compression. So before we started building, we gathered a lot of data on the cardinality characteristics of the string files in production. And the conclusion that we found was that most, but not all strings columns were low cardinality, so most, but not all columns would benefit from the compression. So we were able to set expectations before we jumped in, and we did not do the compression stuff. These examples are like debug statements, right, in production traffic. And one of the reasons that people have not done this is because they haven't had the ability to just send lots of high cardinality shit, which is why you should all pay for Honeycomb, because sorry, it's very frustrating to me that the world is as lacking in cardinality tools as it is. But by having a flow where it's very lightweight and natural for software engineers to add these diagnostic bits, you make it so that people are motivated to look before they leap. You make it so that people no longer want to just like write code and ship it and wait to get paged. That is the worst behavior. I really firmly hope that a few years from now, we look back at this as the dark days, like when we used to just ship code and wait for our pagers to go off. That is insane. That is crazy. Why do we not have the muscle memory of shipping code and then going to look? Did what I expected to ship actually happen? Did anything else happen? Does anything else look weird? The best engineers I ever worked with at Facebook spent half their day in their IDE writing code, half their day in Scuba, understanding the consequences of whatever the fuck they had shipped and their intern had shipped. Testing is great and all, but how do we select our test cases? A lot of this is intuition. Why not use production data to determine which tests are worthwhile? It's really nice to be able to just go look and say, across all the payloads that are hitting our API, what is the distribution, number of columns in each payload? This is why pre-production testing is never going to be enough. Users can fuck with your data in ways you can never predict. That's what makes it fun. We love feature flags, too, for letting us test in production while making sure that the state change is one that we're happy with shipping. Being able to get feature flags in with our dog food cluster means we can look at the normal top-level stuff segmented by tag and broken down by any combination of tag and user and build ID. It's super cool. There are all of these muscle memory habits that like feel opsy, and software engineers, when they start working with us, they're not used to having their hands on these parts of the wheel. But it makes you a better engineer. It really does, in so many ways. It makes you, like if you're not used to looking at your systems while they're normal, you're gonna be lost when you're looking at them when they're abnormal. This is a gut familiarity that everyone who's working with any responsibility for users whatsoever should want to have. It makes you better at your job. It gives you deep intuition and empathy and instinct. It gives you that sixth sense for when things are about to happen. It's really fun. So I'm about done. I'm going to fast forward through those. Oh, this is a super fun thing. Guess what else is high cardinality? Build IDs. Just being able to break down and watch as changes go out and graph them against each other, super fun. That's another example. Build IDs. This is how we help bridge this ops versus dev gap. This is how we try to get people thinking as software owners. And this is how we do development, with observability first. It starts before you even start writing code, by looking at production to see what the impact of what you're thinking of doing is. It saves us so much work. There are so many things that we think of building, and then we go and look, and we're like, oh, this would affect 2 customers. Maybe let's not, you know? And vice versa. There are things that we would tend to put off. We go and look, and we're like, oh, shit, this would save us 30% off of our AWS bill. And having the ability to answer these questions quickly is what makes a system observable. Answering new questions without shipping new code. Why is my thing not advancing? Anyway, yeah, all right. This was an interesting experience between me and these slides here. More lightweight information in prod, blah, blah, blah. End-to-end checks. Oh, and by the way, your reward, if you make the leap from a more black box monitoring type of system into observability, is you can delete almost all of your paging alerts. You should only have to have, latency, errors, request rate, possibly saturation, and then some end-to-end checks around whatever critical code paths make you money. Delete the rest. They are worthless. They are worse than worthless. They are waking you up in the middle of the night and making your life hell. This is just I'll put these slides up on the web so you can see the walk through how the schema evolves. Devs, your mission, Stop writing software based on no facts. Invest in your observability. Instrumentation, like, in the future, observability is entirely an instrumentation game. It is entirely an instrumentation game. Structured data only, instrumentation. Strings can die in a fire. Logs can go fuck themselves. I'm so done with logs, and you should be too. If you do not have someone at your company that is a rabid evangelist for structured data, structured events only, find one or get one, become one. Like, fuck the strings. Like, what are we even doing? It's 2018. String processing is not getting any faster. This wall took a while to build up between devs and ops. It's super annoying. It's going to take a while to tear it down. I actually kind of prefer thinking about it as infrastructure software and ops and product software and ops. You know, the roles are converging. The people with the most power and impact are the people who sit at the nexus of the two. And it's a really fun spot to sit. It is genuinely terrifying to me how many senior software engineers do not seem to understand the systems they have built or are building, and do not seem to be curious about them. But I assume that is none of you lovely people here. So, you know, I feel very strongly about this because of my experience at Parse, where we built this beautiful, rich, marvelous platform. And around the time we got acquired by Facebook, I was realizing that it was effectively undebuggable by some of the best software engineers in the world. And, well, buy me a drink, I'll tell you the rest of that story. It's a better world that we're going to, though. I believe that it is not only a better world in terms of quality, but it is more fun. It is less frustrating, because you can have more power and more impact. And the dopamine hits are going to keep us going. So, we got this. In conclusion, ask new questions. Invest in your instrumentation. Ship better software. Thanks.